All right, so this time we're given velocity, and it's in terms of x. And initially the particle is at the origin, and velocity is 6 minus 2x. So the first thing we're asked to find is the acceleration at the origin. So let's find the acceleration first. Now we know we could differentiate velocity if it was in terms of t, but it's in terms of x. So what's acceleration in terms of some v's and x's? We know acceleration is v to v dx, and that's what acceleration is. So let's just go for it. So velocity is 6 minus 2x, and v dx, differentiate velocity in terms of x, would be negative 2. So you can see we get negative 12 and a positive 4x for our acceleration, but it's at the origin, so when x equals 0, acceleration is obviously just minus 12 when we sub that in. So let's assume it's meters per second squared, even though it doesn't say. All right, so B, show that. Now it's got a t, it's t and x, and remember we did start with velocity. So our velocity we know is dx to t, so now we've got x's and t's, but if I do that, you can see that I need to turn it upside down. So dt dx is equal to 1 over, I'm going to put a 2 outside here, 3 minus x. All right, so let's integrate the left with respect to t and the right. I'm going to put the half out the front, and we're going to do that with respect to x. So you can see we'll get half. Actually, I need a minus up here, so I need to put a minus at the front. So actually, minus a half log 3 minus x plus c. All right, so what am I going to sub in? Well, I know at time 0 from here, time 0, x equals 0. So if I use time 0 and x equals 0, I get 0 equals minus a half log 3 plus c. So you can see c is going to be equal to half log 3. So subbing that back into our equation, we've got t is equal to minus a half log 3 minus x plus c, so plus a half log 3. Now, it is a show that, so usually I would not factorize by negative half. I'd put the positive over the negative, but here we're going to put minus a half out the front. So, yeah, so just a little bit different there. So we're going to have log of 3 minus x on 3, which is minus a half log. So 3 on 3 is 1, and then we've got x on 3 there, which is what we've been asked to show. So there we go, we've shown that. And hence find x as a function of t. So we want to make x the subject. Let's go up here a little bit. All right, so how are we going to do that? Well, first we probably want to multiply both sides by negative 2. So I'm just going to do it here. So I get negative 2t is equal to log of 1 minus x on 3. So if I exponentialize both sides, we get 1 minus x on 3. So 1 minus e to the minus 2t gives me x on 3, and x equals 3 lots of 1 minus e to the minus 2t's. So that will be, what did we have to do? Hence find x as a function of t. So there's x as a function of t. And then part 3, we have to describe the behavior of the particle as t goes to infinity. So here you can see as t goes to infinity, that will affect e to the minus 2t. You can see, again, it's easier to kind of think of it like that. So as t gets bigger and bigger and bigger, this is going to go towards 0. So we're going to get 1 minus 0, which is 1, and times 3. So x is going to go towards 3.